everyone. I am Mary Josna from Andhra Loyola College. Today I am going to deal a basic topic in real analysis, that is continuity. So before defining the definition of continuity, I hope you all know the definition of function and limit of a function. So using those limits of a function, now we are going to define continuity of a function. That is, we are going to say when the function is continuous. So I hope you all know this is nothing but right hand limit. That is limit f of x as x tends to a plus, and this is left hand limit. That is limit f of x as x tends to a minus, and this is nothing but the value of the function at a point a. So a function f is said to be continuous if all these three values are equal. That is, limit of a function at a point a should be equal to the value of the function at a. So that means right hand limit equal to left hand limit is equal to value of the function at a. So this is, we are defining the function, continuity of a function in particular to a point a. Where this a belongs to? This a belongs to domain of the function on which we are defining. So this a belongs to domain and f of a belongs to codomain. Okay. Next, using the limit definition now, we are going to prove or define the continuity of a function in terms of epsilon and delta. This is directly using limits, and this is also using the limit definition, but this is in terms of epsilon and delta. So a function f is said to be continuous if f is defined on some neighborhood of a. That means a belongs to the domain of f. Okay. So f is said to be continuous at a point a if for any given epsilon there exists delta greater than 0 such that mod of x minus a less than delta implies mod of f of x minus f of a less than epsilon. So in particular, to understand, suppose take the domain values on x-axis and the codomain values on y-axis. This is x-axis, this is y-axis. So now we are going to write all our domain values on x-axis. So consider the point A, and you consider delta neighborhood of A, that is a minus delta to a plus delta neighborhood of A, and corresponding to this A or functional value is f of A, and to this f of A you consider epsilon neighborhood, that is f of A minus epsilon to f of A plus epsilon. This is epsilon neighborhood of f of A, and this is delta neighborhood of A. So whenever my x belongs to this domain, the functional values, whenever x belongs to this domain, the functional values f of x should belong to this neighborhood. I hope you all understood. Whenever my x belongs to this delta neighborhood of A, my functional values f of x should lie in the epsilon neighborhood of f of A. Then we say that the function f is continuous with respect to the point A. Okay. So then when do we say that a function f is discontinuous? So there are several types of discontinuities. Okay, the first one is removable discontinuity. So that means here both the left hand limit and right hand limit, both exists, equal, but they are not equal to the functional value. Again I am repeating. The first type of discontinuity is removable discontinuity. In this type, the right hand limit, left hand limit both exist, equal, but they are not equal to the functional value. The remaining types of discontinuities will be continued in my next video. Thanks for watching.